Okay, welcome back to Just Academic Mathematics. If you want to learn and understand how to solve a 3 by 3 matrix eigenvector and value, then I want you to see this video to the end, because in this video I'm going to be treating that in detail. As you can see, we have a 3 by 3 matrix, and we are asked to find the eigenvalues and the corresponding eigenvector of this matrix. So just like we did in 2 by 2 matrix, it's the same procedure. So the first thing we are going to do is to state the eigenvalue characteristics equation. Remember, I told you that the eigenvalue characteristic equation is given as what? Is given as the determinant of s minus lambda times identity equals to 0. This is the eigenvalue characteristics equation. Is constant. This matrix times lambda, this lambda represent the eigenvalues, while I represent 3 by 3 matrix identity. The determinant of it will give you 0. So the first thing we have to do is to go get, we'll proceed to get a minus lambda times I. Of course, this will give us equals to a here is 8 minus 6, 2, minus 6, 7, minus 4, then 2, minus 4, 3. That is this A. Then minus lambda times identity is 1, 0, 0, 0, 1, 0, 0, 0, 1. So if we perform this operation, we will get equals to what? 8 minus lambda times 1 will give us 8 minus lambda, minus 6 minus lambda times 0. Lambda times 0 is 0. Will still give us minus 6. 2 minus lambda times 0 will give us 2. Here, 6 times lambda times 0 minus lambda times 0 will give us minus 6. And 7 minus lambda times 1 will give us 7 minus lambda. Minus 4 minus lambda times 0 will definitely give us minus 4. And here will give us 2. Here will give us minus 4. And then 3 minus lambda times 1 will give us 3 minus lambda. So this one now, look at it here. Are you getting it now? So the next thing we are now going to do is to find the determinant of this equals to 0. That is as it is here now. The determinant of this equals to 0. This is what I mean. Therefore, a minus lambda times I, the determinant equals to 0, simply means 8 minus lambda minus 6, 2, minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda. Now is equals to 0. Okay. So this is now 3 by 3 determinant. We'll go and get the determinant of this. Of course, you know the procedure. We've done that before. So we start with the first one, which is 8 minus lambda times in what? If you pick 8 minus lambda, this will go, you are left with the determinant of this. If you don't know 3 by 3 determinant, go and see the video. This out, we have the determinant of this, which is this 7 minus lambda times 7 minus lambda times 3 minus lambda, then minus 4 times minus 4. That is, then we'll go for this minus plus, plus minus. So we're going to have minus 6. Then open bracket, this is out to find the determinant of these two, this set, which is minus 6 times 3 minus lambda, then minus 4 times 2. Then finally, plus minus plus. So here will be plus 2 bracket. What do we have here? This is out. We have this times this. That is minus 6 times minus 4. Then minus 7 minus lambda times 2. So that is it. If you don't understand this, that means you don't know 3 by 3 matrix. I can't go back there. We've done it in detail. You can go and watch it. We've done a detailed work on that. So this will give me 8 minus lambda times n. If you open this bracket here, this is 21. This is 21 here, minus 7 minus 3. So I'm going to get 21 minus 7 minus 3 is minus 10 lambda. Then what? Minus times minus plus lambda square. Then everything minus times minus times minus is minus. So that is minus 16. Then this time this is plus 6 bracket. If you open this bracket, we'll get minus 18 plus 6 lambda. Then that one will give me plus 8. Then plus 2 bracket plus 24 minus 7 times 2 minus 14 minus 2 times minus lambda times 2 minus times minus lambda times 2 will give me plus 2 lambda. Remember, equals to 0. There is equals to 0. Okay. Now, we expand further. We can expand further from here now. That this will give me x minus 8 minus lambda rather times lambda square minus 10 lambda. Then we have 21 minus 16. 21 minus 16 will give me plus 5. Then plus 6 times 6 lambda minus 18 plus 8 minus 10. Then plus 2 times 2 lambda, 24 minus 14 plus 10 equals to 0. Let's open up. So 8 times lambda square will give me 8 lambda square. 8 times minus 10 lambda minus 80 lambda. 8 times 5 plus 40. Then minus lambda times minus lambda square will give me minus lambda cube plus 10 lambda square minus 5 lambda. Then this will give me plus 6 times 6 lambda, 36 lambda minus 60 plus 2 times 2 lambda, 4 lambda plus 20 equals to 0. It's going to be a long process, so just be patient and enjoy it. Now, let's move on. If we start with minus lambda raised to the power of 3, what will follow? We have 8 plus 10, which will give me what? 18 plus 18 lambda square. Then we have minus 80 minus 5 minus 85 plus 36 plus 36, then plus 4 lambda. That will give us what? That will give us 45, negative 45 minus 45 lambda. 40 plus minus 60 will give me minus 20. Minus 20 plus 20 will give me 0, equals to 0. So, as it is now, if you bring out minus lambda, what will remain? It will remain lambda square minus 18 lambda plus 45 equals to 0. Now, if we equate everything to, we can factorize this one now, of course. We have minus lambda, add to give me 45 times to give me, add to give me minus 18 times to give me 45. What are the two factors? The two factors now, 15 and 3 cannot work. Yes, 15 and 3 should work. 9 and 5 cannot give us 18. But 15 and 3 can give us 18. And it has to be minus 15 minus 3. So we have lambda minus 3 lambda minus 15. If you expand this bracket, you get this by factorization of quadratic. If you know that, equals to 0. So therefore, this first one is equals to 0. That is to say that lambda is equals to 0. S minus 3 equals to 0 will give you lambda equals to 3. S minus 15 equals to 0 will give you lambda equals to what? 15. So these are the eigenvalues. So the eigenvalues are 0, 3, and 15. Can you see? It's the same procedure. So the eigenvalue now is 0, 3, and minus 15. But that is not where the work is. The work is in finding the eigenvector for each of them. So I'm going to remove this. You can watch this over and over in order to internalize it. So let me just place another one on top. Now, we want to find, I will need something from here. Remember, we want to move on to find the eigenvector. We need to proceed to find the eigenvector. Remember that for eigenvector, we say that A minus lambda times identity times vector must always be equal to 0, where V is vector. You know that one. So that is what we need. Because we need this, I want to write this out. This A minus lambda times eigen, which is this one. I need to write it out now, which is 8 minus lambda minus 6, 2, minus 6, 7 minus lambda minus 4. Then 2 minus 4, 3 minus lambda. The multiplication of this with the vector, which can be represented as x1, x2, x3, will always be equals to 0. So with that, we can proceed now. Remember, that we have how many eigenvalue? We have 3 eigenvalues, which are 0, 3, and 15. So let's go. Let's proceed. Eigenvector, now we can call it V1, for lambda equals to 0. For lambda equals to 0. That means we're looking for vector when this lambda now is equals to 0. So anywhere you see lambda, you put 0. You will get this 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 times x1, x2, x3 is equal to 0, 0, 0. Now we want to find the vector. The same procedure for 2 by 2 matrix. We write out 3 equations, 3 linear equation, system of equation by multiplication, row times column, row times column, row times column. So 8 times S1 will give me 8S1 minus 6 times S2 minus 6S2, 2 times S3 plus 2X3 is equal to 0, equation 1. Follow me carefully. We do the same thing, row times column, minus 6 times S1 minus 6X1, 7 times S2 plus 7X2 minus 4 times S3 minus 4S3 equals to 0, equation 2. Then for the equation 3, the last one, 2x1 minus 4x2 plus 3x3 is equals to 0, equation 3. There is another procedure of getting this vector, but this one works perfectly for me and it's easy to understand, less complex. Now the first thing, eigenvector does not mean you should go and find the value of S1, S2, S3. No. What they are trying to let you know, do here is, you are going to find x1, x2, x3 in terms of either s1, s2, or s3. Then you arrange it accordingly to get the vector. So for this equation now, let's find x1, x2, and x3 in terms of x3. So let's start from this first equation. From equation 1, let's make S1 the subject. If we make S1 the subject, you have 8x1 is equals to 6x2 minus 2x3. Are you following now? So if we divide both sides with 8, you have that x1 is equals to 6x2 minus 2x3 over 8. This one we can call it equation 4. Now, we do the same thing with equation 2. Let's make S1 the subject of the formula. From equation 2. From equation 2, let's make S1 the subject again. So if we are making S1 the subject, we are going to get minus 6x1 is equals to minus 7x2 plus 4x3. In other words, minus 6s1 is equals to minus 7s2 plus 4s3 over what? Minus 6. This one is now equation 5. Now, equation 5 and equation 1 is the same thing. That means we can substitute that equation 4 is the same thing as equation 5. Equation 5 and 4 are the same. What I'm saying there is that we can say that 6s2 minus 2x3 over 8 is the same thing as minus 7x2 plus 4s3 over minus 6. So as it is now, we are going to find 2 in terms of 3, s2 in terms of 3. And to reduce the value, we can cancel out here. We will have done that before, but we can reduce the value from here. 2 go here 4, 2 go here 3. So if we cross multiply, 3 times 6 will give me 18x2 minus 6x3 is equals to 4 times 7 minus 28s2, then plus what? Plus, oh, you are not seeing there. Plus where am I? 4 times 4, 16x3. Now remember that we want to make S2 the subject in terms of S3. So let's bring S2 here. We will now have, this process is long, but it is easier. So we'll now have 18, I don't know if you're seeing that, yes, 18S2 plus 28S2 is equals to 16x3 plus 6x3. And of course, 18 plus 28 will give us 46. So we have 46x2 is equals to what? 16 plus 6 will give us 20 what? 22 now. Yes. 16 add for the yes, 22 S3. Are you there now? So we are now to, I hope there is no error anywhere. Okay, so I've seen where the error is. This minus 3 here, minus 3 times 6, here will be minus 18, and minus 3 times 2, here will be plus 6. So by the time we collect the like terms, here will be minus 18, and for plus 6, we come here as minus. So here is negative, not positive. Here is minus 6. So what we have now is minus 18x plus 28, which will give us 10x2 is equals to this 16s minus 6. 16s3 minus 6, that will give us 10s3. In other words, x2 is equals to 10 divided by 10 will give you 1x3. This is S2 in terms of x3. This is S2 in terms of S3. Now we can pick any of these, let's say from equation IV. Remember that x1 is equals to 6x2 minus 2s3 over 8. Anywhere we see s2, we'll replace it with 1s3. So we have x1 is equals to 6 times 1x3 minus 2x3 over what? 8. So x1 is equals to this 6. 6 minus 2 will give you what? 4 over 8. Then what? x3. So in other words, x1 in terms of x3 is what? 1 over 2 s3. That is the value of x1 in terms of x3. The same way, you find x3 in terms of x3 by using any of the equation now. We can say from equation 3. Remember equation 3, let's make s3 the subject. We have 3s3 is equals to 4x2 minus 2x1. Now, 3x3 is equals to 4x2. Anywhere you see x2, you put 1x3 minus anywhere you see x1, you put 2 brackets, x1 is what? 1 over 2 x3, that is x1. So we have 3x3 is equals to 4x3, 2 cancel 2. You have minus 1x3. In other words, x3 is equals to, this side is 3. 3 divided by 3 will give you 1x3. Positive 1x3. So this is s3 in terms of s3. So what we are saying is that this v1, the vector for this eigenvalue 0, v1 is now equals to, what is x1? S1 is what? 1 over 2 x3. What is x2? x2 is what? 1 x3. And what is x3? 1 x3. So to get the value, you can say let this x3 be equals to 1. So the value of v1, which is the vector for eigenvalue 0, is simply 1 over 2, 1, and 1. This is the eigenvector for the corresponding vector for this eigenvalue. It may look long, but it's simple. If you prefer the other method, you can follow, but this is the one I know. Okay, I want to show you, that is, I've gotten the eigenvector, the corresponding vector for eigenvalue when eigenvalue is 0. Now I want to get the corresponding vector when eigenvalue is what? You know, we have 3 eigenvalues. We have 0, 3, and 15. So I've solved for the corresponding vector for 0. Let's go for the corresponding vector for what? For 3. The corresponding vector for 3. So we can pick up from here. We can start from here. Remember that we say eigenvector v2 for lambda equals to 3. But remember the equation, that the equation is what? 8 minus lambda minus 6, 2, minus 6, 7 minus lambda minus 4, 2, minus 4, 3 minus lambda, times in x1, x2, x3 must be equals to 0, 0, 0. Now, when lambda is 3, what do we now have? That is all we are solving for now. So when lambda is 3, we now have 8 minus 3 to give us what? 5 minus 6, 2, minus 6, 7 minus 3 will give us 4, minus 4. Then 2 minus 4, 0. Times in x1, x2, x3 is equals to 0, 0, 0. Now the same thing, you derive 3 equation again. We derive 3 equation, starting with this. Row times column, we have 5x1 minus 6x2 plus 2x3 equals to 0. Equation 1. Then row times column again, minus 6x1 minus 4 plus 4x2 minus 4x3 is equals to 0. Equation 2. And 2x1 minus 4x2, 0 will give you that one, equals to 0. Equation 3. So again, we are going to remember equation 1. From the first one we solve for eigenvalue of so remember that we had to find S1, S2, S3 in terms of S3. So don't change the pattern. We are going to find S1 here, S2, and S3 in these 3 equations in terms of S3. If we have find in terms of S2 before, we retain in terms of F2. Don't change this thing, or else you will miss it. You can find everything in terms of S2, but the previous one will have been in terms of S2. S2. But since we have found the previous one, the vector for eigenvalue of 0 in terms of S3, we are going to find this one in terms of X3. Now, in terms of S3, let's do the same thing again. We are going to find S1, S2 in terms of what? S3. Let's, from equation 1, we make S1 the subject. So we have 6S2 minus 2S3 here. So X1 is equals to 6S2 minus 2S3 over what? Over 5. This one becomes equation 4. We do the same thing here. We find X1. We make S1 the subject in equation 2. So from equation 2, we know that minus 6x1 is equals to 4x3 minus 4x2. So we have that x1 is equals to 4x3 minus 4x2 over minus 6. This is equation 5. Equation 4 and equation 5 are the same S1. So we can equate both of them. We can say therefore S1 is equals to S1. That is equation 4 is equals to what? Equation 5. What does that mean? That means that 6x2 minus 2x3 over 5 is equals to 4x3 minus 4x2 over what? Minus 6. So we'll cross multiply. Remember, this minus is going with this. So 6 times this, we get minus 36x2 plus 12x3 is equals to 5 times 4, 20x3 minus 20x2. So we can proceed here again. Let's proceed here. We make S2 the subject in terms of S3. So we have minus 36x2. Another S2 here is plus 20s2 is equals to 20s3. Then what? Minus 12x3. Minus 36 plus 20 will give me what? 16x2 is equals to 20 minus 12 will give me what? 8x3. Therefore, x2 is equals to 16 divided by 8 will give me what? That is 16 over 8 over 16 rather, x3, which we can write as 1 over 2 s3. So s2 in terms of s3 is 1 over 2 s3. Are you there now? Now we can pick this, one of these, to find s1. Remember, from equation 5, we can find s1, or even from equation 3, but we can use equation 3 to find we have gotten s2. We are looking for s1. Even assuming we even use this, it will even be, faster. But there is no cause for alarm. We are still looking for. Let's go. We'll have just used this. We'll have finished this instance, but there's no problem. So let's go there. So x1 is equals to 6x2 minus 2s3 over what? 5. So x1 is equals to 6. In the place of s2, you put 1 over 2 s3 minus 2 s3 over what? 5. So x1 is equals to, this cancel this 3. So you have 3. Yes. Yes, 3 minus 2. Is that what is going to be? Yes. S3. In the place of S2, yes. So I have 3 minus 2. Okay. So I've noticed another error here, and I just have to quickly point it out. Please look at this. Minus 36 plus 20 is minus 16. So here is going to be negative, and here will be minus 1 over 2. So here is negative here. So 6 2 into 6, 3. That will give me minus 3s3 minus 2s3 over 5. And 3s3 minus, that will give me minus 5. Minus 5 divided by minus 5. That is it now. Minus 5 divided by 5 will give me what? Will give me minus what? Minus 1. Minus 1. Minus 1 x 3. Okay, so let's find the remaining one, S3 in terms of S3. We can use any of these since there is no S3 here. Can put S1, S2 there and find S3. So if we're using the first equation from equation 1, for instance, so 5x1, anywhere you see x1, you put minus 1x3. Minus 6s2, anywhere you see s2, you put minus 1 over 2 x3 plus 2s3 is equals to 0. We're looking for this s3. So we have this minus 5, or rather we have 2s3. When this minus 5 come here, it becomes 5x3. And when this one we're looking for, when this one come here, plus, it will be minus, this cancel this 3s3. So we are having that s3 is equals to, this will give us 2. 2 divided by 2, 1s3. Are you following now? So we are now declaring that V2 is, what is S1? S1 is minus 1x3. S2 is what? Minus 1 over 2 x3. S3 is what? 1x3. So if you let S3 to be equals to 1, then V2 will now be the same thing as minus 1 over 2 and 1. So that is V2 for you. Now we go for V3. We'll solve another one for V3. Okay, so let's finish up. Let's solve for the vector. This is the last part of the equation. So this time around we are solving for eigenvector V3 for lambda equals to, what is our third answer, Seth? I think it's 15. That is 15. Lambda equals to 15. I need to copy out this again. So once again, we have 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, then 2 minus 4, 3 minus lambda, times in x1, x2, x3 equals to 0, 0, 0. So that is what we need. Now we can now proceed to find the vector, the corresponding vector, when the eigenvalue is 15. So we are now to substitute 15 here. We are to put the value 15 here. If we put 15 in the place of lambda, 8 minus 15 will give us what? Minus 7. So here is minus 7 minus 6, 2, minus 6. 7 minus 15 will give us what? Minus 8 minus 4. 2 minus 4, then 3 minus 15 will give us what? Minus 12. Times in what? x1, x2, x3 is equals to 0, 0, 0. It's an interesting process. It may be long, but the other one is quite confusing for me. Now, we derive the equation again, row times column, row times the three equation. So minus 7x1 minus 6x2 plus 2x3 equals to 0, equation 1. We'll do the same thing again with minus 6 times s1 minus 6x1 minus 8 times s2 minus 8s2 minus 4 times s3 minus 4s3 is equals to 0, equation 2. Then the last one, 2 times s1, 2x1 minus 4x2 minus 12x3 is equals to 0, equation 3. So we do the same procedure again. We find x1, s2, s3 in terms of x3. So let's make s1 the subject here from equation 1. From equation 1, we know that what? Minus 7x1 is equals to 6s2 minus 2s3. So x1 is equals to 6s2 minus 2x3 over negative 7. We call this equation 4. We derive equation 5 from equation 2 by making s1 the subject. We have minus, or rather, first, from equation 2, we have that what? Minus 6x1 is equals to 8x2 plus 4x3. Divide both sides with minus 6. We have that x1 is equals to 8s2 minus 4x3 over what? Minus 6, equation V. The equation V and equation IV, 4 and 5 is the same. Equation IV is equals to equation V. What I'm saying is that 6x2 minus 2s3 over negative 7 is the same thing as 8s2 minus 4s3 over minus 6. We can cross multiply now. So we have 6 times minus 6 times 6 will give me minus 36x2 plus 12x3 is equals to 7 times 8 will give me minus 56x2 plus 28x3. Then we can now collect like terms. Just like the same thing we did before. Let me put it here because I will need that space. If you bring S2 here, we were looking for in terms of S3. So we're going to get positive 56S2 minus 36X2 is equals to 28S3 minus 12S3. This minus this will give me what? Will give me 20. 20. I guess. Yes, 20. So I have 20x2 is equals to 28 minus 12 will give me what? Will give me... Okay. I've spotted another error here. This thing is... this place is plus here. This plus here. Plus 4. Where is it? So here is plus. So because here is plus, this 28 here will have to be negative. So this is negative 28, not positive. So here is negative. So negative, we're going to have negative 40 minus 40x3. Which therefore means that S2 is equals to minus 40 over 20 S3. So S2 is equals to what? Minus 2 S3. So this is the value of S2 in terms of S3. So now that we know S2 in terms of S3, we can use from equation 4. From equation 4, we know that x1 is equals to 6x2 minus 2x3 over what? Negative 7. So anywhere we see s2, we can substitute this. So s1 is equals to 6 times s2 minus 2s3 minus 2s3 over what? Minus 7. So this will give us what? Minus 12x3 minus 2s3 over minus 7. Minus 12 minus 2 will give me minus 14. Minus 14 divided by minus 7. Minus 14 divided by minus 7. Minus 14 over minus 7 s3. So s2 is simply what? 2s3. This is the value of s2. So we are now to find s3 in terms of s3 from equation, let's say equation 3 now. Let's make this s3 the subject. Just bring this s3 here. Then we'll have 2x1. 2x1. What is x1? x1 is, what's happening here? s2. No, this is 1 now, not 2. So s1, in the place of s1, in this equation, we'll replace it with what? 2s3 minus 4s2. In the place of s2, we'll replace it with what? Minus 2s3. Then it's equals to what? 12s3 when you bring it this side. So this is 4x3 plus 8s3 is equals to 12s3. Remember, this is one we're interested at. So if we divide both sides now, we'll get that what? x3 is equals to what? 1x3 in terms of what? 3. So we conclude again that V3, which is S1, is what? 2S3. S2 is what? Minus 2S3. S3 is what? 1S3. So if S3 is equals to 1, then V3, the vector, is 2 minus 2 and 1. So that is it. We have gotten all the vectors. So it may be long, but it's worth it. So this is the corresponding vector for this eigenvalue of 15. You can watch it again to understand this. For eigenvalue of 3, this is the corresponding vector. And then for eigenvalue of 0, this is the corresponding vector. Then this is the one we saw first to get the eigenvalues, 0, 3, and 15. So you can watch the video over and over again to internalize it. Most students avoid eigenvector. The other method, please, is shorter, but I don't really know the other method. This is the method I know for finding the vector. Thank you. And we'll continue in our next class. Remember, if you need me to teach you mathematics one-on-one, just send me a message via the WhatsApp contact showing on the screen now. And make sure you are following us. Share this video. Let other people see it. Share it on all social media platforms. Share it on Facebook. Share it. Just share. Keep sharing so that more people will benefit, and that will also encourages us to do more, because our goal is to run through the entire mathematics, no matter how long it's going to take us. Thank you. See you in our next class.